Here we have another implicit differentiation example problem, and we want to find y prime by using implicit differentiation. So our example is 7y squared plus sine of 3x, which is going to be equal to 12 minus y to the fourth power. So the first step in solving this example problem is we want to take the derivative with respect to x of each of our components. So when we evaluate each of these components, we can see that the first one will need to use the chain rule. In the second one, we'll need to use the chain rule. In the third one, it's just a derivative of a constant, so that will go to 0. And then in the fourth one, we need to use the chain rule as well. And when evaluating the chain rule for terms that have a y in it, we know that y is really just y of x, or a function of x. And so we know that this term y really reads as y of x, and we'll have a inside the y term and an outside function. So that is why we'll need to use this chain rule. So let's go ahead and take the derivative with respect to x. We'll do our outside function first. So 7 times 2 will be 14. We'll keep this inside function the same, so we'll have y, and then we'll take the derivative of y of x, which will give us y prime. The second term, sine of 3x, we'll use the chain rule to take the derivative of the outside term sine, which will give us cosine. We'll leave the inside term alone, and then we'll take the derivative of the inside term, which will give us 3. So we're left with 3 cosine 3x. Like I said earlier, this 12 will go to 0. And then on the fourth term, we'll do the same thing where the 4 will come out in front. We'll have y cubed, y prime. After that, the next step is we want to simplify our y prime terms on one side. So you can see here we've left this term on the right side and we've moved this term to the right side. Then we're going to go ahead and factor out this y prime term and then solve for y prime. So after taking this term and dividing it to the other side, we're left with our solution.